Question 5. This says the mass M in kilograms of 120 newborns at a hospital is recorded in the table below. So N is equal to the sum of the frequency. This is 120. We're to state the modal class. The modal class would be the class with the highest frequency. The highest frequency is 30, and that corresponds to the class 4.4. M is less than or equal to 5.3, but greater than 4.4. So the modal class is M is less than or equal to 5.3, but greater than 4.4. Complete the table below and calculate an estimate of the mean mass of the 120 newborns. All right, so here's the thing about midpoints. Midpoint generally go by a specific amount. So if we take away 3.05 from 3.95, what we get is 0.9. So it's going up by 0.9. So 4.85 plus 0.9, this is 5.75. Now 6.65 plus 0.9, and we get 7.55. Now, over to the right, we have the frequency times the class midpoint. So 5.75 times 29 gives you 166.75. 7.55 times 8, that gives me 60.4. So next I need the sum of fx. So I'm adding everything to the right. We have 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4, and I'm getting 651.3. Now we're asked to calculate an estimate of the mean. The mean, or an estimate of the mean, x bar is equal to the sum of fx over n. So this is 651.3 divided by 120. So the mean is 5 point, and this is 4.3 to 3 significant figure. The mean is 5.43 kilograms to 3 significant figure. Now, one newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3 kilogram. So let's have a look at the table and determine how many newborn has a mass greater than 5.3 kilograms. All right, well, this class here starts at 5.3. So all of these newborns have a mass greater than 5.3 kilograms. So that's 29 plus 28 plus 8, that is 65. So the probability that the mass is greater than 5.3 kilograms is equal to 65 out of 120, which reduces to 13/24. As a decimal, it's 0.542 or 54.2%. So of course, you don't need to write all of that. You could have just stopped at 65 over 120 or 13/24. But I generally like, whenever I talk about probability, I normally like to state them in percentages. So there's a 54.2% chance that if you select a newborn at random, that newborn would have a mass greater than 5.3 kilograms. All right, so next, we're getting information. We need to complete the cumulative frequency. Cumulative frequency means that you are adding the frequency as you go down. So let's see what the frequency is when the upper class boundary is 6.2. So here it's going to be 55 plus. So 6.2. Let's see what the last three frequencies are. 28, 29, 28, 8. 29, so that's plus 29, plus 28, plus 8. So the cumulative frequency here is 84. Now 84 plus 28, the cumulative frequency here is 112. Now 112 plus 8, the cumulative frequency here is 120. And that is sort of helping us out a little to show that yes, we're accurate, because the frequency must add up to 120. So next we're going to plot this information to draw the graph. All right, so when it's 5.5, when the upper class boundary is 5.5, no, it's actually 5.3. When it's 5.3, we get 55. With a cumulative frequency of 55. So 5.3 corresponds to 55. This is going up by 0.05. So two of them would be 0.1. So this is 4.6, 4.7. Am I correct? 4.8. No. No, I'm not. Each of them is, one of them is 0.1. So 5.3 corresponding to 55, that would put me here. .3 corresponding to 55 would put me there. The next one is what? 6.284. 6.284. 6.284. 6.284 would put me there. Then 7.1, 7.1, 112, 7.1, 112. That would put me here. And 8 corresponds to 120. That would put me here. So once I have all my points, I can now draw my cumulative frequency curve. Dropping the ball near the end. I'm not going to start over. All right, so here's our cumulative frequency curve. Let's see if they have any questions on it. All right, and here's what they're asking now. Use your diagram to find an estimate of the median mass of the newborn. So the median mass would be the mass of baby number n over 2. N is 120, so n over 2 would be 60. The mass of baby number 60 would be your median. So at 60, I draw a horizontal line. Anywhere it cuts the graph or it meets the graph, I draw a vertical line down. And this is for me. Yours don't have to be the same thing. But mine sort of looks like, it's probably even closer. It's actually very close. It's so close to 5.5. I'll just say 5.5. But if you said 5.95, I would work with that. So I would, if you said 5.45, I'd work with that, or 5.5. So the median and of course, the notation for median is Q2 is 5.5 kilograms.